Maybe. I don't know yet.
Good.
Because it depends. My
We're looking
mom
at three
hasn't
things
decided
today.
she's letting me go with her.
We're looking at
or
converting
if I can
between
go without
degrees
her.
and radians, finding and sketching coterminal angles, and converting between decimal degrees and degrees, minutes, seconds. Those are the three things we're looking at today. Now, they are somewhat difficult to explain, but once you get to the point to where you're actually working them, they're pretty easy to work. Okay? All three of these are pretty easy to do, but they're difficult for me to explain, so you need to hang in there with me, and we'll get it explained. And then once you start working on it, you'll see that it's pretty easy to work. All right. So first thing we want to talk about is radian measure. Radian measure is what we want to look at. Okay, so far we've looked at measuring an angle using degrees. Now we want to look at measuring an angle using radian measure. There are two things that factor into an angle when it's being measured with radian measure. Those two things are the radius and the arc length. Radius and the arc length are the two things that factor into a radian measure. What do we mean by arc length? Who can help me out on what arc length is? What we're talking about. It is the length of the arc. What are we talking about on arc? What do you mean by arc? Part of a circle. All right, good. All right, so let's say I have that angle right there. My arc length would be the circular shaped part of that length, or of that angle. So I would have my radius down here at the bottom, and then I would have my arc length. An angle that is in radian measure is made up of the ratio of the arc length over the radius. That's how we get something in radian measure, is you take the length of the arc divided by the length of the radius, and that tells me the measure of the angle. So, what would make an angle measure out to be 1 radian? What's going on if an angle measures 1 radian?
That's the same.
The radius and the arc length are equal. Very good. That is 1 radian, is when the radius and the arc length are equal. What would be an angle that would measure out to 2 radians?
Arc length is double.
Arc length is double the radius. Okay, so 3 radians would be where the arc length is triple the radius, and so on. So that's how radian measure is measured. Okay. Now, to help us talk about the relationship between an angle that's measured in radians and between an angle that's measured in degrees, we want to look at a specific angle. So let's say I've got my initial side here, and let's say I'm rotating all the way around. So what type of arc length would I have? Wouldn't my arc length go all the way around as well? Okay, and what is an arc length that goes all the way around and makes a full circle? Circumference, very good. You guys should remember circumference. Circumference from geometry. What's the equation for circumference from geometry? Pi r squared is area. Pi d is 1, but when we're dealing with radius, what can I make it? 2 pi r. Very good. So circumference would be 2 pi r. So let's say that my radius is 1. So let's say my radius is 1. When I plug 1 in there, that makes my circumference equal to what? 2 pi. So my circumference is 2 pi, and my radius is 1. And what's another word I can use instead of my circumference that we just found? Arc length. So my arc length is actually 2 pi, and my radius is 1. So that makes my radian measure what? 2 pi. So what we need to realize is that if I'm going all the way around, my radian measure is 2 pi. And what do we know is all the way around in degrees? 360. So that means 2 pi in radians is equal to 360 degrees in degree measure. All right, let me stop for a second and answer any questions you might have. Any quick questions before we move on? Camille?
I have lots of questions actually. So like, how'd you get from 2 pi r to just 2 pi? Like, where'd the r go?
Because we said our radius was 1, so if I stick 1 in for r, 2 pi times 1 gives me 2 pi.
And you made that up?
We just picked a radius. It doesn't matter what the radius is.
Okay.
So for instance, if I say my radius is 3, what would my circumference be? If I plug 3 in here, what does that give me? 6 pi. But radian measure is when I take the arc length over the radius. So my arc length is 6 pi. My radius is 3, and what does this reduce to again?
2 pi.
2 pi. So that means when I go all the way around, no matter what the size of my radius is, that angle measure in radians is always going to be 2 pi.
Okay.
Other questions? So far we've got 2 pi equal to 360. What's something I can do to both sides here to kind of simplify it? Divide by 2, and that tells me pi is equal to 180 degrees. So I now know that if I take something and rotate it there, and that's my terminal side, in radian measure, what's the length of that angle? The length of that is pi. That is correct. And this right here is what we're going to use to convert between radians and degree measure. That's going to help us get our conversion factor to go back and forth.
So the arc length is just the two pi or whatever. It's
Yep.
just that part without the radius. That's always going to be the arc length.
No, that's 2 pi is always going to be the 2 pi is always going to be the radian measure. The arc length, if I'm going all the way around, the arc length over the radius will always reduce to 2 pi. Okay? Originally, we stuck in 1.
Yeah.
We put 1 in there, which gave me 2 pi over 1, and 2 pi over 1 gives me 2 pi. Then we took another one, my radius was 3. I stuck 3 in there, that gives me 6 pi, but when I take that and put them on top of each other, it always reduces to 2 pi. Okay? So that's, we just use that to figure out how far is it all the way around. That's what we use that for. To figure out that all the way around in radians is 2 pi. And then that leads us to halfway around is pi equals 180. All right, so now we're going to use this to help us go back and forth between some angles. So let's start with 120 degrees. So let's say I want to turn 120 degrees into a radian measure.
Ew.
And we said we wanted to use this fact right here to help me switch back and forth. Now in science, when you are converting between units, what do you usually have to happen?
A ratio?
There has to be some form of ratio, okay? So that means I need to take pi equals 180 and turn it into a ratio by dividing 1 to the other side or 1 to the other side. So the question is, to get rid of degrees, what needs to be in the denominator of my ratio? Degrees does. So what do I need to do to both sides right here to get my ratio? Divided by 180. So that means the ratio I want is going to be pi over 180. So I'm going to take this and multiply by pi over 180. Okay, I know I'm doing this right because the degrees units cancel out. So my degrees units cancel out, and when I multiply, that gives me 120 pi over 180. And now I want to reduce this. So obviously the zeros cancel, and what's something that goes into 12 and 18? 6, so that gives me 2 pi over 3. So what we've done is we've figured out that 120 degrees is the same thing as an angle measured in radians, which would be 2 pi over 3. So the radian measure of 120 degrees is 2 pi over 3. The key is, when I'm going from degrees to radians, I need to multiply by pi over 180. Alright, let's go the other direction. This time we have 5 pi over 6. And we want to go from radians to degrees. We want to know how much is this if I measured it in degrees. And again, we're back here to pi equals 180, but this time what do I want in the bottom? I want pi in the bottom. So that means my conversion factor is going to be 180 over pi. So times 180 over pi. And what happens nicely for me there? The pi's cancel out. I can reduce 6 and 180, both of these, by what? 6. So that goes away, and this turns into 30. And then I go 5 times 30, and I end up with 150 degrees. So an angle measured in radians as 5 pi over 6 is the same thing as an angle measured in degrees, which would be 150 degrees. So 150 degrees is the same thing as 5 pi over 6. So that's the first thing I want to do is be able to convert back and forth between degrees and radians.
Ooh, what was on the bottom of the second thing?
This was 180 over pi, and this was 5 pi over 6.
Thanks.
So if I want to change degrees to radians, what do I multiply by? Pi over 180. If I want to change radians to degrees, what do I multiply by? 180 over pi. Okay, and who can explain how an angle measured in radians is measured? It is the length of the arc length divided by the length of the radius. That's how radian measure comes about. All right, so there's our first one. Next thing is coterminal. Talk about coterminal angles. Okay, and understanding coterminal angles, it's all in the name of it. Coterminal. So remind me, before we get into it, remind me what are some things I need if I'm going to draw an angle? I need 2 rays. What are the names of those 2 rays? Initial and terminal. What's the other thing I need for an angle?
Vertex.
I need a vertex, but what else do I have to show? I have to show the rotation. Okay? So keep that in mind. Coterminal angles. What does co mean? What? Together. Okay, what's another name or another word I can use to describe co? With, or what I'm thinking of is share. Co means, if I'm going to be co-captains, that means we share the responsibility of being captains. Okay, so in this case, if I have angles that are coterminal, what does that tell me? They share the terminal side. That's what coterminal angles are. So let's say I have the angle 135 degrees. So I have my initial side over here. I've got my terminal side right there, and I have the rotation that gives me 135 degrees. Somebody come up with and tell me what's an angle that's coterminal to 135 degrees. David?
It's 225, or 225.
Negative 225. All right, I'll go with that. So he gave me a negative angle. So he went this direction, and he told me that that angle is negative 225. I'll go with that. Somebody else have their hand raised? Who's saying it? I asked for somebody give me an angle that's coterminal to 135.
495.
495? Okay. So you are taking it, you're going past it and all the way back around, and that gives me an angle of
What the heck?
495 degrees.
Is that supposed to happen?
Yes, you can have
Oh
them.
my
That can happen.
gosh.
Okay, so we talked about this before. Does people just like know this?
We talked about it on Friday.
Oh, okay. I was like, wowzers.
I'm ashamed of myself. So.
All right, now, Hayden, what'd you do to get 495?
360.
You added 360. Because, why'd you add 360?
So if we can go around.
So I can go right back around and end up in the same spot. David, what'd you do to get negative
I was here.
225?
I wanted to make it
Makes sense, kind
equal
of.
360 or go all the way around, so I just took the negative portion of it.
feel like I'm gonna throw
All
up.
right. What I wanted him to say was that he took 135 and subtracted 360 from it. Is what I wanted to hear him say. Okay. But all three of these angles, what do they have in common?
Coterminal angle.
They share the same terminal side. But they're not the same angle. Why are they not the same angle?
They have different rotations.
They have different rotations. So coterminal angles share the same terminal side. And how do we find coterminal angles? By either doing one of two things.
Subtracting 360.
Adding or subtracting 360 is how we find coterminal angles. So what you're going to have to do in your assignment when you get to these is they're going to ask you to find a positive coterminal angle and a negative coterminal angle, which means I have to add 360 or subtract 360 to get what I want. Yes. Okay, so let's do another one.
So for a positive, you add 360, negative, you subtract 360?
No, that won't help.
Unless it's already the angle, I guess. Yeah.
So
I don't really know.
They have to be in the exact same place. To be correct. Because there would be coterminal. To be coterminal, they have to have the same terminal side. They have to stop at the same
I'm
spot.
serious. My body's going to withdrawals.
All right, so let's look at 45 degrees. First thing I want to do is sketch 45 degrees. Then after that, I want to find a positive coterminal and a negative coterminal angle. So what quadrant is 45 degrees in? It's in quadrant 1. Where is it at in quadrant 1?
Halfway in each one.
It's right in the middle. So I've got 45 degrees right there. But I must show my rotation to begin. Now I want to find a coterminal angle. So Hunter, what can I do to find a coterminal angle? Add or subtract 360. So if I add 360, which means I'm going to go past it and all the way back around, what would that angle be? Or wouldn't it be 405? Okay, and Bailey, what would I get if I subtracted 360? Either one. Either Bailey. Either Bailey. Negative 315. So I end up with my original angle is 45. A positive coterminal angle would be 405, and a negative coterminal angle would be negative 315. How many possible coterminal angles are there for each angle? And infinite, because all I have to do is keep adding 360 or keep subtracting 360. I can get as many
I'm serious,
I can get as many coterminal as I want. We're just looking for one that's positive and one that's negative.
My work is giving
Now, what if?
free to the workers. And I just didn't feel like it was. I feel like you should because you kind of contact the sick people. Yeah.
All right, let's look at one that they give me in radians.
Because if I get the food, then I don't have to go to work.
So they're going to give me an angle in radians, and they want me to find my coterminal angles of the radian.
I swear I work at things.
Okay, very good.
Huh?
We'll get there.
Tia?
Don't worry about it.
What was the question?
All right, first thing I need to do is graph 4 pi over 3.
Ah, girl. Why did you do that first?
So, what's something that might help me figure out where 4 pi over 3 is at?
Turn it into degrees.
Turn it into degrees, Hayden. And how would I want to do that?
By multiplying it by the deal.
180 over pi is what I want to multiply by.
Wowzers.
So my pi's cancel out. And divide by 3, and that gives me 60. So that means we're dealing with 240 degrees. So 4 pi over 3 is the same thing as 240 degrees. So Michael, what quadrant is 240 in?
Quadrant 3.
It's in quadrant 3. How do you know it's in quadrant 3?
90, 180, 270.
Okay, what?
So you're telling me
It's in between.
what I'm looking for is that 240 is in between 180 180 and 270. That would have been good for me. Is 240, Levi, is 240 closer to 180 or 270? It's 240 degrees. Is it closer to 270 or 180?
I know this one.
270.
Gotta keep your head up.
No, I wasn't paying attention.
Yes, I can tell.
Yes.
All right. So here's
There's a coat
240.
on.
All right, there's that. So there's my angle 4 pi over 3. Now I need my coterminal. When we had degrees, we added and subtracted 360, but now I'm dealing with radians. So instead of adding and subtracting 360, James, what do I want to add and subtract? What's all the way around in radians? I know, but how much is it all the way around? How many radians is all the way around?
Oh, one.
Get it. I don't
You said it was
know.
2 pi.
Don't you remember we said 360 is equal to 2 pi? And what did we say to get coterminal angles, and I'm dealing with degrees, what do we do? To get coterminal angles, if I'm dealing with degrees, what are my two options? Add or subtract 360. So if I'm dealing in radians, what am I going to add or subtract? I'm going to add or subtract 2 pi. So I want to do 4 pi over 3 plus 2 pi. But what do I have to do to be able to add those two together?
Change the bottom.
Okay, what would it change to?
Okay, so like, why are you doing that? If you have 240, why wouldn't you?
Because I want the answer in radians. If they give it to me in radians, I want the answer in radians. So if you want to find the two in degrees and then convert those two to radians, you can do it that way. I would rather take it in radians and then from there find the other two.
Radians sounds like aliens.
But you can do it the other way.
I'm serious.
What?
Why do we have both? Why can't we just use degrees?
I think if you say that to Coach White, he might punch you.
Because in calculus we only use radians. We don't use degrees. You need both, that's why. Alright, so what do I have to do to 2 pi to be able to add it with 4 pi over 3? Common denominator. So what do I need to do to 2 pi? Multiply by 3 over 3. So that gives me 4 pi over 3 plus 6 pi over 3, and so I end up with 10 pi over 3. Now I need to show that rotation. So that is all the way around and back to it. That gives me 10 pi over 3. Okay, now I need the one where I have to do what? Subtract. So now I need 4 pi over 3 minus 6 pi over 3. And what does that give me? Negative 2 pi over 3. And then I need to show that rotation, which would be right there. So I have sketched my original angle, I found a positive coterminal angle, and I found a negative coterminal angle. That's what we're looking at doing there. The key is to find coterminal angles, I need to add or subtract what? 360, and if I'm in radians, 2 pi. You always find coterminal angles by adding or subtracting 360 or 2 pi, depending on if you're in degrees or radians. So that is how we find coterminal angles. Okay? Gabby, how do coterminal angles get their name? Why are they called coterminal angles? Very good, because they're sharing the terminal side. Excellent. Yes. All right, so let's look at decimal degrees in degrees, minutes, seconds.
Aw, okay.
Alex, you don't even worry about it. I'm not worried about it because I gotta teach us something. I'm ready.
Yeah. Yeah, like last week. Thank you. I haven't watched it since then. That's good.
All right, so decimal degrees and degrees, minutes, seconds.
I don't know.
With decimal degrees, that's what you guys are used to dealing with. It's when I have something like 153.256 degrees. It's called decimal degrees because it's in degrees and we're using a decimal. That's decimal degrees.
Whoa.
What you're not used to is an angle being given to you in degrees, minutes, and seconds. that is used in the aeronautical world, the boating world, and
The alien world.
surveying
Right.
and the surveying world. Okay, has to mainly do with longitude and latitude. If you're giving the location of something with longitude and latitude, it's going to be given to you in degrees, minutes, and seconds, and not decimal degrees. Reason being is you can be a whole lot more accurate with degrees, minutes, and seconds than you can be with decimal degrees. It would take a very long decimal to get as accurate as degrees, minutes, and seconds. And degrees, minutes, and seconds is a lot easier to write, as you will see. An example of something in degrees, minutes, and seconds would be 32 degrees, 21 minutes, and let's say 43 seconds. That's an example of what degrees, minutes, seconds would look like. Okay? What we want to do today is to go back and forth between something that's in degrees, minutes, and seconds and something that's in decimal degrees. So we want to take something from degrees, minutes, and seconds and turn it into decimal degrees and vice versa. Now, the two that I have written up there are obviously not equivalent to each other. I'm just saying that that's what, I was just using those as examples as what we're going back and forth between. So, we're going to start out by going from degrees, minutes, seconds to decimal degrees. And we'll go ahead and use this one I have up here. But again, if I'm converting, that means I need conversion factors. And a minute is equal, I'm saying that wrong, 60 minutes is equal to 1 degree, just like you think it would be. 60 minutes is equal to 1 degree, and 60 seconds is equal to 1 minute. So if 60 minutes is in 1 degree and 60 seconds is in 1 minute, how many seconds are in 1 degree? How much?
3,600.
Yes, 3,600. So there are 3,600 minutes or seconds in a degree. How'd you come up with that?
Definitely not.
60 times 60 gives me 360 or 3,600. So that's what I need to be able to convert between minutes and seconds and into decimal degrees. Now, the degree part is always there. You never touch the degree part. The only thing that changes are your minutes and your seconds. So when I'm converting this, 32 is going to stay there. The 21 minutes and the 43 seconds are going to turn into a decimal. That's where the decimal comes from.
32 stays where?
Just let me finish, and then it should fall into place. So 32, nothing happens to 32. It stays there. All right? Now, I need to change 21 minutes into degrees. What do I do to 21 minutes to turn it into something that's a degree measure?
Divided by 60.
Divided by 60. So we want to go plus 21 divided by 60. That will turn my minutes into a decimal. And then what am I going to do to my 43 seconds? Divided by 3,600. That will turn my seconds into a decimal. So I divide my minutes by 60. I divide my seconds by 3,600. And now I'm ready to put that in my calculator, and it will turn it into decimal degrees. So we go to the calculator.
Way to have your calculator out.
All right, so we're going to do 32 plus, my first one was what? 21 divided by 60. And then I'm going to go plus, what was the second one?
43 over 6.
43 over 3,600. Now, if I press enter right now, what will the calculator give me?
A
It
fraction.
will give me a fraction. So what can I do to make sure it won't give me a fraction?
Push push period.
Put a decimal in there and then press enter. So now you see that 36 degrees, 21 minutes, and 43 seconds is actually 32.36194 with the forwards repeating.
How many decimals do we need?
I only want you to give me 3 decimals. But the point I want you to make, the point I want to make right here is, I initially said 32 degrees, 21 minutes, and 43 seconds, and look at this long decimal that it gave me. That shows you how accurate minutes and seconds are, but without having to write as much. Okay? So, my answer would be 32.612.
That's decimal degrees.
So, this is decimal degrees. So, 32.612 would be my degrees. That's if I took that from degrees, minutes, seconds, and changed it into decimal degrees. Now we want to go the opposite direction.
So I have a question.
Yes.
Well, okay,
So by degrees, degrees like temperature wise?
No. I mean like degrees and angle wise.
step in there.
I guess.
Not degrees Fahrenheit or degrees Celsius. We're talking about degrees and angle.
I do like that for decimal degree.
Decimal part is a part of an angle, part of a degree. It's part of a degree. The 21 and the 43, they're parts
It's
of
like
a degree.
cool.
Okay? Alright. Yes. 21 minutes would be 21/60 of a degree. 43 seconds would be 43 3600ths of a degree.
Why did they use minutes and seconds like that?
No. I don't know why they named it that. It's probably because they're broken up into 60s. That's probably why they use minutes and seconds.
That's why I was really.
Alright, let's finish up.
I didn't think it was
We need to go the other direction and we're done for today. So now we want to turn 32.612 degrees into degrees, minutes, seconds. So we should get something very close to what we started with. Why would it be slightly different?
I wrote all this.
That's accurate.
Alright, I'm using a rounded number. So we'll see how close we can get. Alright, now remember, the part in front of the decimal never changes. So I already know that that's going to be 32 degrees. My job is to turn the decimal into minutes and seconds. So we kind of need to do the reverse of what we just did. What did I do to the minutes to get a decimal? Divided by 60. So what am I going to do to get the minutes? Multiply by 60. So the first thing I want to do is take my decimal times 60. So I'm going to do 0.612, and I'm going to go times 60.
You didn't tell me.
All right, so let's try that again. Where are we at? Give me something. There we go. 0.612 times 60. So that gives me 3672. The number in front of the decimal gives you the minutes. So that means my minutes are 36. Well, something went wrong. What did I punch in wrong?
The decimal should be 362, not 61.
Oh, that's where I messed up. Thank you.
The decimal should be what?
362.
I was missing a number.
362 instead of 612. I'll just make. It's just the number.
So 362. Let's try that one.
Oh.
It's just
Alright, so 0.362 times 60. Now, the number in front of the decimal is my minutes. So you see that it's 21, and 21 matches what we had. So 21 minutes is correct. Now, to get your seconds, you take the decimal of what you got right here, the 0.72, and I times it times what, do you think?
3,600.
You would think 3,600, but it's 60. Why am I not multiplying by 3,600? Because I've already multiplied by 60 one time. So if I multiply by 60 another time, that gives me the 3,600. So times 60, and that tells me my minutes are, take the number in front, which would be 43, and we happen to get the same amount. Erica.
If you wanted, could you do
So you did 0.72 by 60?
That would give you your minutes, but it would skip right by and not give you that. I'm pretty sure. So let's see if that works. That's a good question. So 0.362 times 3,600.
If you're architecture.
No, it doesn't work.
Well, I'm not going to.
Yes.
This would make more sense.
from the back part of that decimal.
Every day.
Hello. Yep.
Check me out, baby.
Sure.
So how do
All right, so
can you give us like steps I can write
I will.
down something?
If I'm going from degrees, minutes, seconds, if I'm going from degrees, minutes, seconds to decimal degrees, what do I do to the minutes? Divide by 60, and what do I do to the seconds?
By 60.
Divided by 3600. And I add all that together, and that gives me decimal degrees. So divide by 60, divide by 3600, add it together, gives you decimal degrees. If I'm going the opposite direction, and I have the decimal degrees, and I want degrees, minutes, seconds, what do I do to my decimal? Multiply by 60, and the number in front of the decimal becomes my minutes. Okay? And then what's behind the decimal, I multiply by 60 again, and that becomes my seconds. So I take my decimal times 60, that becomes my minutes. Whatever is left over as my decimal of the minutes, multiply by 60, and that becomes my seconds. So, converting between degrees and radians.
Okay,
What are my
so
two
if you
conversion
want-
factors?
As if you're starting out as this.
Pi over 180 and
So this.
180 over pi. When I'm converting between degrees and radians.
I have 60.
Coterminal. I'm either adding or subtracting what?
360.
360 if I'm in degrees, and what if I'm in radians?
2 pi.
2 pi. And converting between decimal degrees and degrees, minutes, seconds. Divide the minutes by 60 and the seconds by 3600. If I'm going the opposite direction, I take my decimal times 60. I take my new decimal times 60, and that gives me my minutes and my seconds.
Exactly. And what is the
I feel like this lesson is saying like